So let's start off this chapter on regression by this cute cartoon. Thinking, why is that woman scowling at me? Do I know her? And underneath, if she loves you more each and every day by linear regression, she hated you before you ever met. So, when is it appropriate to use linear regression? And obviously, this is an example where it's not so appropriate. So first of all, some things we want to do when doing linear regression is we want to look for groups. So we want to display the residuals to check that the linear model is reasonable, and also to reveal subtleties that are not clear on the original data. What can subtleties do? They can confirm or refine our understanding, and they reveal violations of regression conditions. So it is a good idea to look at both a histogram of the residuals and a scatter plot of the residuals. I definitely want to see a scatter plot of the residuals. Histograms are great too. So if we look at the histogram here for a certain set of residuals, you can see it's somewhat symmetric. It's fairly symmetric. Almost normal, but not exactly. So that looks pretty good. That's what you want to see in residuals. But the thing is, when we look at certain groups that are in different colors here, you can see that these groups are actually kind of separated. So what do we see? We see that these green dots, which represent a higher calorie count than expected, these are from your book, and these red squares here represent lower calorie counts than expected. So we want to look for groups that are different than others, and we can analyze those groups separately with their own models, and that's usually appropriate. It's important that all data must come from the same group. However, when we discover that there's more than one group, we have to choose. Are we going to look at them individually or together? No matter what we choose, the model will always be wrong because it's got different groups, but it may be useful. So even if you have to look at things separately, it might reveal some interesting information. So here's some regression lines fit to calories and sugar for each of three cereal shelves in a supermarket. So green is the top shelf, where the adults normally shop. Blue is the bottom shelf, probably where those little elementary school kids are. And 2 is the middle shelf, probably where that toddler is reaching from the grocery cart. So if you look at the data, you can see that there are different correlation lines here. Here's the red and the blue. Those are pretty similar correlation lines. But the green one, as you can see, is markedly different than the other two. So it would be appropriate to model the top shelf data separately from the other two shelves. Okay, primarily those other two shelves, again, are more geared at kids, and the top shelf is more geared towards adults. Another thing we want to do, use residual plots for, is to look for patterns in the residuals. So if it's a good residual plot, there should be no pattern. But one nice thing, if there is a pattern, sometimes it's hard to see that pattern in the original scatter plot, but it becomes more obvious when we do the residual plot. So here you can actually see there's a curved relationship. It's not so strong here on the left, but it starts to really show up on the residuals. So there's actually a slight curve to this. It's not quite so linear. So it's more obvious in the residual plot than in the original scatter plot. So there are several reasons you want to do the residual plot when doing a regression analysis.